Hello, my name is Flora Huang, and I'm from Philadelphia, USA.
Hello, we are Women in Data Science.
I became a WIDS ambassador because I dream of an equitable world where empowered women help humanity make better decisions through data science.
As a woman, I'm hoping more Peruvian women will be motivated to join this exciting field.
The WIDS community has really enhanced my sense of purpose in these life goals, and it has really built my confidence in such a meaningful way to be able to mentor, motivate, and support others.
The most rewarding and impactful aspect about my work as a clinical data scientist is to use the data generated by doctors, nurses, and the healthcare system to improve the care of future patients.
I'm delighted to bring this event to Pakistan, along with so many WIDS ambassadors worldwide, so that we can inspire all young girls or women to take up career in data science.
The use of data science to address climate change and sustainability issues continues to inspire me in my data science journey.
Through WIDS Alexandria, I've got the chance to meet with brilliant female professors, learn about the research, and bring that to my community as well.
I'm a WIDS ambassador because I wanted to inspire more young girls like me to join the field of data science, and I believe that in the future there must be more women in this field.
I'm really excited to continue bringing WIDS events to my school and schools across Australia to empower girls to get involved in the field.
It's great that we've got Women in Data Science events, and know that there's so many more inspiring stories as part of the Women in Data Science journey.
Hi, I'm Carolyn Bertozzi, and I am a chemist who works in the area of drug discovery. I've had many opportunities in my life to collaborate with data scientists. They've been absolutely central to the work that we do. We couldn't have made the discoveries that we've made without having people to analyze very large data sets and to help us find hidden trends within them. Now, when I was growing up, I was somewhat insulated from the idea that women or girls couldn't be scientists because I came from a family of scientists. And when I was in college, I learned that not everyone had that privilege. I hope that all of you women data scientists or aspiring data scientists will truly feel that you belong in the field, because I believe it, and your participation is absolutely essential for us to bring the full benefits of data science to solve the big problems in humanity. So just as I was so fortunate to have a family that created an environment where I could believe in myself as a scientist, I'm hoping that you all have the confidence to pursue your dreams and that you help the generation that follows you in the same way that hopefully someone of my generation can be of help to you. Good luck with all of your work.
Good evening, everyone, and welcome to the Datathon workshop series. I am Setha, Ambassador of WIDS Sri Lanka, your host for today's workshop. We are thrilled to have you here as we embark on this exciting journey of learning and discovery. Our workshop series promises to be a valuable learning experience, and we have some fantastic guest speakers lined up to share their insights. Before we dive into today's workshop, let me give you a brief overview of what WIDS is. It is an organization with the aim to empower women to reach their full potential in the field of data science. We elevate and celebrate the outstanding work of women on a global scale, fostering respect, collaboration, connection, and visibility. The WITS community creates access to programs, content, and resources that inspire, educate, and support so that vibrant voices and ideas can be shared with the world. Let me give you a brief introduction of WITS Global Datathon Challenge. Guild Science is the sponsor for this year's WITS Datathon, and the challenge theme for the Datathon 2024 is Equity in Healthcare. We are thrilled to announce that it is the 7th annual WITS Datathon competition. Participants are tasked with developing a model to predict if the time for a patient to receive their first treatment for their diagnosis is within 90 days of their metastatic cancer diagnosis. Datathon is designed to help you discover whether desperate treatment exists and to understand the drivers of those biases, such as demographic and social factors. The primary goal of building the model is to detect relationship between demographic of the patient with the likelihood of getting timely treatment. The first challenge is health inequity, as it has become a global challenge. Addressing this challenge has an extensive positive impact on women's health, which is key for societies and economics to thrive. We have provided a rich worldwide dataset which contains treatment insurance provided about patients who were diagnosed with breast cancer from 2015 to 2018. The timeline of the Datathon Challenge was first started January 2024 and ends in March 2024. And the Datathon Challenge second starts April 9, 2024 and ends on June 7, 2024. The WITS Datathon is open to individuals or teams of up to 4. At least half of each team must be individuals who identify as women. You can connect with Global WITS Datathon participants with the WITS Datathon Slack, WITS Datathon Kaggle, and WITS Datathon Workshop. So I welcome you all to be a part of the Worldwide Challenge Datathon 2024. Without further ado, let me introduce today's distinguished guest speaker, Ms. Sachini Bamunusinghe, Senior Engineer, London Stock Exchange Group. She is an expert in the field of data science. We are honored to have Ms. Sachini Bamunusinghe here with us today to share her knowledge and insight on data science and machine learning. Ms. Sachini, the virtual floor is yours. Please enlighten us with your wisdom and expertise. Thank you.
Thanks, Sweta. Thanks for the introduction. So hi everyone. As the introduction said, so I'm Sachini Bamunusinghe, and I currently work as engineer in London Stock Exchange, mainly focusing on data analytics and automation. And my study area has been in statistics, but currently I'm sort of in the IT side of it. Yeah, so I warmly welcome everyone to the session. So this is the first session of the series that is leading to the workshop. And in this session, we are planning to cover the introduction to data science and machine learning. And I hope you all will be engaging in the session and we can carry on with a useful discussion about the topics that we are going to cover. So the flow or the overview of the session that we are going to follow for this 1 hour and more is going to be mainly overview of data science and its applications. And then we'll go through an introduction to machine learning and its types. And then we'll discuss about the importance of data in machine learning, and then the real world examples of ML applications in healthcare, because in this session series, our main focus is in the healthcare sector. So that will be the flow of the session. At any point, feel free to unmute yourself and then ask any questions that you have. More than welcome. So when talking about introduction to data science, most of you would have the question, what is data science? So that's the most basic question that anyone would have. And if you go and Google in a web in Google, like what is data science, you might get like a plethora of definitions as to what is data science. And one such of definitions I have added here, which is from Wikipedia, which is like the first result, but most of them would go along this definition, which is data science is an interdisciplinary academic field that uses statistics, computing, scientific methods, processes, algorithms, and systems to extract or extrapolate knowledge and insights from potentially noisy, structured, or unstructured data. So all the definitions would be along the same line, but the key phrases that all of them would have in common would be the interdisciplinary academic field phrase, and then the whole point of this data science, which is to extract or extrapolate knowledge and insights from the data. So those would be the keywords in all of those definitions. So what is interdisciplinary academic field? So data science is broad. It's broader than one existing field, whereas it's a merge of many fields. As you can see in the below Venn diagram, we call data science Venn diagram. You can see that it has elements of computer science, IT, or maths and statistics, which is my background from my university days. And then it also have the domain or business knowledge. So what data science aims to do is give a solution to a business problem that we have in our day-to-day life. So in order to give this solution, a person has to have a business or domain knowledge, at least for some extent, to go forward with the solution. And then they have to have the computer science and the maths and statistics background. They don't have to be a pro, but at some degrees, they have to have this knowledge in order to continue successful in the field. So a person who engages in data science is usually called a data scientist, which has become like a it keyword in the recent years due to the demand that it has. And data science essentially covers the process of how the data is stored, processed, and then analyzed and then used for predictions. So whole process is falling under the umbrella of data science. So that's a brief introduction to what data science is, but then data science is a really deep area of knowledge. So this is, since we have limited time, I'm just going to go through a brief introduction. Sweta, if you can go to the next slide. So the next question, like now we know what is data science, then the question we might have is what's the importance of data science? So in simple words, data science is crucial for informed decision making, extracting insights from data, and then predictive analytics for future trends. So if we ask ourselves, how did people come to decisions in the earlier times when there wasn't much of a technology around data? In order to say, okay, what product I'm going to market in this season, or am I making a loss? Am I going to make a loss? And things like that. Does anyone have an idea what method they have used? Because I think it would have been purely intuitive if not for a small number of data usage. But currently, since there's a lot of data, brands are utilizing them to understand the customers, understand how to market their brand, how to communicate the story, and then understand the competition, and then have an edge on the brand or the product that they are pushing forward to the customers or the public. So, and then there's this term called big data that is coming up in most of the discussions, which is we'll discuss in later stages of the session. So basically, the importance of data science is to utilize the data in a manner that it can be used to optimize the processes and then have an edge in the business problem that we are trying to solve and the product we are going to promote, or any that kind of solution that we are looking for, we can have an edge in those areas using data science. So that's the importance of data science in the discussion that we are having. And yeah, so there's a whole science around data. So how much data do you think is out there for there to be a science around this data? So unless we have like figures in numbers, we might not have better idea. So when we see numbers, we get the idea faster. So that's why I have added like this statement here, which sort of gives an idea about how much data that is there that we are dealing with, that I'm referring to as data here. So it says the volume of data being generated globally is immense and is measured in zettabytes, which is like a trillion gigabyte. I mean, 1,000 gigabytes is also already a huge number, but imagine trillion gigabytes. That's going to be like a amount that we can't even imagine. So this is already a huge number, but then it's predicted to multiply in large numbers in the coming years, 2025, 2026, likewise in the years to come. So this is where the value is. So that's why this whole buzz is around data science, and everyone is trying to learn different methods that's used in data science and utilize the ways to take use of data. So that's how much data that is out there. And where does this data come from? Because there are many sources of data in current day and age. So I have compiled a list of data sources that we have in the current day, where it generates a large amount of data. For example, if we take social media, which is like something that almost everyone use, for Facebook, Twitter, Instagram, every post we put there, every comment we put there, and then every story that we update there, it's a chunk of data. It contains information about our lifestyle, the products that we use, and then the connections that we have, and then the interest that we have. So this is like a lot of sentiments of people, and this is like a large wealth of data that is currently being used by organizations to get value from. And then we have Internet of Things. Internet of Things is something like a net of devices. It can be sensors, smartphones, and software devices, where they are connected through internet, and then they can communicate to each other, and then one device can get the information from another device regarding a status of the process and things like that. So these devices generate alerts, status updates, and all these things by the second. So that's another large wealth of data source, that Internet of Things, or IoT. And then we have business transactions. So in the current day, we have a lot of e-commerce platforms coming up, and then we have a lot of transactions that's happening online. We buy things online, we pay via online, and then we use delivery services and all of these things. We do all of this online. So there's a lot of data that is regarding the payment methods, and then the market baskets, and then also about the logistics of all these payments and e-commerce that is there out there, that can be used in useful ways to generate value. And then we have scientific research done on all these areas of interest, like healthcare, environment, technology, and all of these things. So that's that. And then we have agencies conducting censuses and like weather censuses and all of these things that deliberately collect data, and they can be in huge numbers. For example, if it's like a yearly census, then that's going to contain a lot of information about the citizens, and then other infrastructure and things like that. So that's another big source of data. And then we have the gold of data, which is the web data. So if you take Google, for example, everyone searches Google daily, like more than once. per day in my case. So if we take like a minute, it says that it's 6.3 million searches per minute worldwide. Imagine all the information that can be gathered from this data. So yeah, I'm trying to make a point here, which is that there's a lot of data out there. That's why there's a whole science surrounding it, and that's why we have to make use of this data and get the better use of them. And then as I mentioned, there's a term called big data, which is to address the fast growing complex collection of data that is not just the traditional data. It can be of different formats, structured, unstructured, and then these can't be handled using the traditional ways of handling data. So this separate field is coined as big data. So that's the subset of data that we are talking about. Yeah, so that's a small introduction to data. I hope I'm not going too fast. If there's any questions or anything that you want to clarify or any thoughts you want to add to, please feel free to do so. Even unmuting yourself is fine. So yeah, I think we can move forward. So this is like an infographic that I thought would be interactive. As we talked about how much data is generated in e-commerce. So this is an infographic called 1 minute in the e-commerce world, which shows the numbers, like figures related to each platforms that we generally see in the e-commerce arena. You can see the numbers are in millions and billions. Yeah, so that's for me to make a point, like how much data is there. If we move on for the next slide, Sweta. Now we have talked about the general surrounding of data science. We are sort of trying to get into the technicalities of it. So this is now we are going to talk about how the data science works. In the raw sense, the process can be explained in 3 steps, which is collecting data, analyzing data, and then the insights. But then we have a well-defined process called data science life cycle, which is of 6 steps, and there can be few variations of it, but I'm going to use this one, where each step is very important for the process, and we can't skip one step and go for the next step, because the successfulness, like the degree of successful of our project depends on each step, each completion of each step. So that's why it's called data science life cycle. And if we go into each step briefly to discuss what happens at each stage, the first step is understanding the business context of the problem. As I mentioned in the data science Venn diagram as well, a person who is working with data science, a data scientist, has to have some kind of a business context, be it healthcare or any other field. They don't have to be a pro in healthcare, but then they have to have some kind of idea of what happens in the business side of it, so they can try to interpret this problem into a data science problem. So we have to have the framework of what the issue is, not essential issue, but the problem is, and then what are the objectives or the end goal of this whole process. So if we have a problem, then we know what's the output is, and then we can access the successful, whether our whole process was successful, or we need to go for another cycle and things like that. So usually at this stage we ask questions, many questions, and some questions we ask to identify what kind of a problem is it, for us to decide the next steps. So there are multiple types of problems that we can find. There can be trying to understand how much or how many things that we are going to require in numbers, which can be a regression problem, and then trying to decide which category something is going to fall, or something like that, then it's going to be a classification problem. And then if we have a problem where we need to find different groups within the data that we have, then it's going to be a clustering problem. And then if we trying to see something that is out of place or weird in a sense, then that's going to be an anomaly detection problem. And then if there's a situation where I need to figure out which option that needs to be taken, like what is the best option among a set of options, that's going to be a recommendation problem. Don't be scared by the words that I'm using. I'm trying to simplify some of the problems that we might see in the future sessions, and we'll discuss throughout the sessions. So that's where the business understanding comes, and it's very crucial, because if we don't understand the problem we have, no matter how much data we have, we are not going to get a successful result. Yeah, so that's the first step of the data science life cycle. And once we have decided what's the problem that we are going to solve and what's the objective of this problem and the goals, then we have to start collect data, because sometimes data can be out there if there are already existing research or things that you can scrape from the web. Then we can scrape it, and then but this is the most time consuming and labor intensive stage, because data is not really easy to come by, because there's multiple sources. We might have to get data from different sources, and then this consumes a lot of time and effort. And few questions that we can ask when trying to collect data or data mine, which is a term used in data science for collecting data, is what data that I need for my project. So what type of data, of which quality, and focusing at what area, what type of data. And then we have to understand where does it live or where does it exist. Is it in a database, or is it out there in the web, or where is it? And then what's the way to obtain it? Can I use some kind of a pre-existing pipeline or something like that? And then what is the most efficient way to access, store and access, basically? So can we have it in a local machine? Can we have it in a cloud storage? Things like that. These are questions that we usually try to find answers in this stage, which takes most of the time in this process, I guess, related to data mining and then the data cleaning. And after we have collected all the data that we believe we need for the project, then we move on to the data cleaning stage, because data doesn't come like really organized, looking nice. We can start right away working on it. It comes like in a really unorganized manner, and there can be inconsistencies, missing values, and things like that. So that's why there's a step called data cleaning, where we prepare the data that matches for the problem we have. Because otherwise it can cause errors, and it might not prove useful at the later stages if we don't clean it and prepare it properly. Once we have prepared, next stage in the process is the data exploration. So we can start analyzing the data to see if there are any patterns, if there are any biases in the data. And if we need to form hypothesis around our problem, then we can start doing these things in this stage. If we are like looking at a relationship between two variables, we can build hypotheses around those two and check things. So this is where the data exploration happens. And this is useful for the next stages, because it gives us a better understanding of data and what are the elements of data, like features of data that we have. So yeah, that's the data exploration stage. Next, in the life cycle, we have the feature engineering. I believe we have separate sessions for all of these stages, but I'm going to run through them to give an overview of all the process. That's why I'm sort of giving like a brief introduction for all the stages. In machine learning and data science, we have a thing called features, which is sort of like a different representation of the data. So it helps us to understand the model, or like how the data would behave and the problem we are trying to solve. It can be better explained using features. So that's where the feature engineering comes. It sort of improves the accuracy of the model and sort of improves the model that we are building to explain the problem that we are focusing on. And once we have engineered the features, next comes the predictive modeling. So this is when the machine learning that we'll discuss in the later stages would come into picture. Based on the previous question that we decided on, we can utilize multiple machine learning methods that are out there, where once we supply the data that we have, we'll be able to give some predictions out of it, and then we can evaluate the success of these predictions and then keep improving, and then decide what's the solution or the prediction that we are looking for. And then the final stage of all of this process is the data visualization. So all of these stages that I explained so far is for the tech people. So if someone doesn't understand data science or anything that I explained here, like the normal person, they wouldn't be able to understand what we are trying to say using this machine learning. This model is like this. They don't have any use of that. What they can understand is it has to be explained in simple visuals and interactive manner, where it has to take into consideration of like the psychology, statistics, and communication skills, and all of these in talent, like the skills. So this is the important part, because no matter what we have done in the previous stages of the cycle, if the customer or the end user can't understand what the data is trying to say, what was our solution, what was the problem, and how did we come for the solution, and what they should be looking into the future stages, none of those can be understood if we can't explain the solution well. So that's where the data visualization comes, where we explain the derived insights in a captivating manner so the end user can understand and interpret it. So once all of these stages are done, do you think we are done? Because this is cycle. Once all these steps are done, we go back to the drawing board, which is the first stage, where we again try to go through the business understanding. So now we have a set of understood things that we found from the cycle, and then we try to see whether this tackles the problem identified, the solution that we got, whether it tackles the problem identified, does it give any tangible solution that can be used in a real business scenario, and are there any new insights? We go back to the drawing board and we again go to the stage one. So this is a never ending cycle until we get the exact solution we are looking for. This keeps continuing. So this is the data science life cycle, and how a data science project would usually flow through. And is there any questions so far from whatever that is presented? If not, I'll move forward with the interest of time. I don't want to sort of breeze through the last slides. So now we know how the data science process works. Now we are going to sort of look into some examples of data science use around us. So as it says, data science is everywhere. You can find it in different areas like marketing, social media, automation. I have highlighted this many times already. Travel, healthcare. It it's sort of interdisciplinary, and it can be used in any case because it's not limited to any single area. It can be used anywhere we want. If we have a business problem and then we have data, then we can use the data science problem for the most part. Sweta, if we move to the next slide, I'm sort of like listing few day-to-day life use cases of data science. So this data science can be used for fraud detection and prevention, mostly in financial settings, where for example, if an online transaction is happening via a credit card, then if it's an anomalous transaction, or is there any other unusual patterns in this transaction, this all can be monitored using data science, and that this is really useful for the institution as well as the customer that is doing the transaction. So that's like one use of data science in day-to-day life. And I have added an infographic which sort of explains how this is done. It uses inbuilt ML models, and then it takes real-time insights, and then it sort of take actions on these insights to prevent the fraud. And then another use case in real life of data science is the predictive analytics. So for platforms like Amazon and then these Alibaba and all of these transactional platforms, they can use data science and machine learning tools to predict what will happen, looking at a pattern in customers buying history, and then related products and things like that. They can do predictive analytics on the buying patterns. And if we move on to the next use cases of data science, this can be used to optimize business processes. Just like a few examples of how that is done. There's an airline called Delta Airlines. They utilize data science to optimize the flight scheduling, pricing, and then any booking and rebooking patterns. To this, they use the historical data and seasonal changes and all of these things. And then they have used this to optimize their models. So they have a better understanding of how their transactions and all other processes happen, so they can optimize the business. And then we can make informed decision making. For example, we can take Netflix, where it uses data science algorithms to analyze user preferences and viewing patterns, similar to how transactional platforms work. And they also cater to the user depending on their preference, and then they also have tried to identify what are the genres that people are mostly inclined to watch, and then they have even created new TV series or movies depending on these genres that they have identified. So that's how far they have used data science that we see in our day-to-day life without realizing. If we move on to the next set of some examples. Another thing that is discussed in the arena of data science is smart cities and urban planning. Smart cities where a city that contains a lot of sensors and other information that they utilize to the betterment of the citizens living, and then they use it to reduce energy consumption and all of these things. And then we have personalized marketing, similar to the previous ones that I explained, where person would get marketing ads and all these things cater to themselves. So these are few examples. When I explained, I feel like you might feel related to most of them, because these are like day-to-day scenarios that you might have seen them. So yeah, it's around us and we are already using it without even realizing. Since we have seen many examples of how data science is used, let's look at the potential of data science field, like in the next slide. So I think many of you are interested in field and might consider it as a career option as well. So in that case, what's the potential in the field? I have listed some statements from different institutes that work in relation to labor and then career and all these things. So all of them, they say the same thing. They say that it's an up and coming field, and there's a lot of opportunity as there's a lot of data, and then there would be more and more openings for people to get into the field. So yeah, that's good to hear. And then the other side of the things are, because people keep innovating and the whole field is about taking away things that people have been doing manually and transforming them into automated processes. The field has seen some new trends where they are trying to see whether we can simplify all of these processes, because we don't need to train people for a long time to be data scientists. They want to make intuitive tools that is easy for the use, and anyone, even not even an undata scientist, can use. So that's the other side of the coin. So there's like two sides for all things, and the key thing that keeps recurring in this field in terms of career wise is that people has to keep updating themselves with the current trends, with the new technology, and you have to be on top of them. If some technology is changing and being discarded, then you have to be updated to the newest technology that is coming up, so you won't be left behind in the field. So that's about the potential is in data science field and what opportunity we have. And if we move on to the next slide, so far we talked about what is data science, introduction, and all of the aspects related to data science. But the second part of this session is about machine learning. So data science and machine learning are two different technologies. They are not entirely exclusive, but then I wouldn't say data science the whole of machine learning and vice versa. And you can see there's a Venn diagram where it says data science and artificial intelligence are two entities, and then what they have in common is machine learning. And so usually data science helps produce insights, and then machine learning usually produce predictions that can be used for insights. So data science often incorporate machine learning in the process of giving the insights. So data science can't exist totally without machine learning. It requires some it at some stages, but then we can't say this is like same thing. So what I would say is data science and machine learning are two distinct fields with their own objectives, and they are closely intertwined together to derive insights using machine learning technologies in the data science. So usually if we're talking about a data science job, it requires ML understanding of machine learning, and then languages used for creating machine learning algorithms and models like Python and some languages like that. So that's the connection between data science and machine learning. And let's move on to the next slide, which is the introduction to machine learning. So machine learning is, as it says, concerned with development of algorithms and techniques that allows computers to learn like humans. So it's concerned with building like computational solutions, but if we look into the underlying of all, like the granularity of it, it's still statistics, but then it has improved into a level where it's sort of like can learn things on its own and proceed further. So, but one difference between the traditional programming and this machine learning is that in the traditional programming we know the rule set, and then we have full control of it, and we know the outputs and all these things. But then in machine learning it's a bit different than that, and it's where we provide the input, and then there's different weighting systems and things, algorithm that sort of gives an output where it can predict, it can come into a decision based on these inputs that we provide. And some common machine learning techniques that we use in more frequently are some like regression scenarios, and then we have classification scenarios and things like that. So this machine learning can be used in various scenarios, like to recognize like image recognition, natural language processing, where we try to process the natural language and try to use it in machine learning, and then things like that. So that's a brief introduction to what machine learning is. And if we move on to the next slide. So another question that we might have is why we use machine learning, why we can't do it. So there are a lot of use cases why we can't do or why we use this. So in certain scenarios, the human expertise might not exist. So for example, when the first human went to Mars, then no one knew what to expect. So we couldn't build any role-based system or anything like that to how to process things that we see in there. So in these scenarios, we need machine learning. And then when the humans can't reduce their expertise into a rule set, when we can't really define all the things that we do into a specific scenario of rules, then machine learning has to be used. One example is speech recognition, where we can't explain how to identify a voice, how to dissect what's being said. We can't reduce it to a rule set. So in this scenario, we have to bring in a machine that can think like a human, but then can work in far more efficient ways and than a human. And then some solutions need to be adapted automatically. For example, user personalization that I mentioned in transactional sites, and then other e-commerce sites where we can't keep track of all the transactions that's happening in a site by ourselves, by humans. So there has to be a way to keep track of all of these things that is happening, and then give proper personalization suggestions. So in these scenarios, machine learning has to be there. And then there are certain situations where it can change from situation to situation, like junk email. We can't predict what the junk email is going to be. So in those scenarios, and then when the data amount is large, that is outside of capabilities of human comprehension, then the machine learning has to be used. And then finally, when humans are too expensive to use, because human is a source of labor that has a value, so we can't use it unconditionally, it has a value. So in those scenarios, machine learning has to be used as a cheap option of computing and other things. So I'm sort of moving a bit fast because we are sort of having a bit of a time constraint here, but if you have any questions, feel free to ask away. So when talking about machine learning types, these are separated depending on the problem that we are going to solve, as I explained in the beginning of the machine learning data science life cycle. We have to define the problem properly, and then depending on this problem, we can identify 3 types of machine learning problems. That is supervised, unsupervised, and reinforcement learning. Supervised is mostly task driven, where the human says, okay, this is this, I need you to do this. And then unsupervised learning is where we don't know what we want. We are not sure what we are going to see from it, but we know generally that we want to see a group, or we want to see some association, but we don't know any rules or already known things about this data. So in those scenarios, we use unsupervised learning problems. And then there's reinforcement learning, which is a bit of a different to the first two, which we use both of these qualities and learn from mistakes when learning. And yeah, so let's dive into the machine learning types one by one. The first machine learning type is the supervised learning. Shweta, if you can move to the next slide, please. Yeah, so when talking about supervised learning, as I mentioned, we use labeled data sets that includes like the inputs that we are giving to the machine learning algorithm, and then the correct output, which is labeled. So, and then we train the algorithm saying that, okay, if this is the input, this is the expected output. Likewise, we train the machine learning algorithm to recognize the patterns in the data that we feed. And then once the data is fed to the model, it adjusts the weights depending on the input, and then build a pattern that matches the labeled output. And this way, when a new data point comes that doesn't have a labeled output, it sort of tries to match for the weights and then identify what's the expected output of this set of inputs. There are multiple learning methods because this is the mostly used supervised learning, if I'm guessing correctly, in machine learning. There are many methods that we use. For example, neural networks is where we sort of has imitated how our brain works, how signals pass through each neuron of our brain, and we have built a learning algorithm based on this system, where all the inputs from the beginning pass through different nodes of this network, and then they would assign weights and then biases, and then match them to a certain labeled output that we know. And using this method, we can learn about the problem. And then we have linear regression and logistic regression, 2 types of the same kind of technology model. So it's used to, linear regression is used to identify relationship between dependent variable and independent variable, where the dependent variable is a continuous value, whereas logistic regression is used to identify when the dependent variable is not continuous but rather categorical. How we do is we try to build like a line of best fit between the variables that we have, and then try to find where the new inputs would fit in this line of fit. So I'm not going to explain them in great detail because all of our following sessions would cover them with examples of codes and other information. So that's why I'm just running through them just to give you an idea of what are the different types, so you can look forward to in next sessions to learn about them. And then we have few other methods such as support vector machines, naive Bayes, k-nearest neighbors, and random forest, whereas they use different techniques, but at the end of the day, they use the same methodology of having a label set of data and then learning about the pattern that already exists there, and then trying to predict the new inputs using this pattern that is already learned. If we move on to unsupervised learning, which is a second type of machine learning, it this is where we don't know the labels already, where we know that the data is this, and then the problem we want to solve is this, but we don't know what kind of answers we are looking for. For example, if we have a set of data and we need to see useful groups between them or clusters between them, we don't know what the clusters are, but we want to see clusters. So in that case, we can use unsupervised learning. So usually unsupervised learning is used for three main use cases, which is clustering, association, and dimension reduction. So for clustering, what it does is it tries to identify the similarities between the inputs, and then create groups between the data, and then separate them from each other, and then identify clusters. There are different methods of clustering that we see that is currently being used, such as k-means clustering, where it sort of takes initial groups, and then they try to identify the average of those values, and then try to see the distance between each group and use such a method. And then things like hierarchical clustering, where they use a hierarchical method by using a bottom-up approach, where data points are isolated, and then they would be gathered using logical matching. And if we talk about association, it's more like towards the market basket analysis, where we are trying to find a relationship between certain inputs, where one thing is bought by a customer, what's the chance that they are going to buy another thing likewise. And then we have another use case of dimension reduction. So since I mentioned that we have a huge amount of data and with large complex sizes, so with this comes the problem of noise and high dimensions of data, which is hard to handle. So in these scenarios, we can reduce the data into a lesser number of dimensions by taking the useful features out of them, and then converting them into a different set of dimensions than they originally was. So these are like few use cases of unsupervised learning. And lastly, if we move to the reinforcement learning, it's essentially a mix of both. It can't be classified specifically as unsupervised or supervised because it requires labeled data, but then it works on classifying data points. So it's sort of like mix of both. The basic idea behind this is that it learns to correct its mistake by looking at the different scenarios. So it's a cycle of learning where each output is again validated, sort of again checked upon to see whether it was correct output or not, and then it's relearned from its mistakes, and then try to improve the algorithm that way. It's mostly used in robotics and other scenarios where it learns by itself to improve the algorithm. And so these are like few examples of machine learning methods that we see in our usual use cases that we create algorithms for. And if we move on to other important things like importance of data in machine learning. So we have data science, and then we talked about machine learning. So what's the importance of data in machine learning? So as for data science as well, data is sort of like the crude oil for machine learning. Without data, then we won't have machine learning. it's useful for training models. So the training unit of machine learning is data. And then it's sort of useful for feature representation. As I mentioned, we have to build features for the models to learn of the data. So for that, in order to build the features, we have to have the data. And then for generalization, we have to have data for the model to learn continuously. So it's helpful in generalizing, and then it's also useful in evaluation. So once we train, the next important step is evaluation and validation to see whether the output is correct. So for this as well, the data is the important thing. And then it's that it's important for many reasons, and some of them, as I explained, it's for training models and driving insights for decision making. But then overall, data is sort of like the lifeblood of machine learning. So that's how important data is for machine learning. If we move on to the next slide, if we talk about like, okay, we know the current applications of machine learning and data science, but what are the future applications? So since we have worked in machine learning and data science for some time, we have lessons that we have learned for this, that we can improve, use these lessons to improve the current technologies and make them for the betterment of humankind. So one such scenario is people are focusing more on explainable AI. So AI or machine learning for the most part is known as a black box, because no one can really explain in a detailed manner what happens in a artificial intelligence solution, because most of the time it sort of like learns on its own and things like that. So there's a huge interest on making this technologies more interpretable, because especially in finance sector, there's a need for the things or methodologies that is used to be explainable and transparent. So when we give an advice for a person to invest in a certain thing, and then if the person asks back why is the reason, we can't say it's a black box. So it has to be interpretable and explainable. So that's why the importance is in explainable AI. And then there's the focus on ethical AI and responsible data science. So you might have heard some time back in 2010s, where there's this huge scandal and court case going around regarding Facebook, Cambridge Analytica, where they have used data of the Facebook users without their consent, and then use this for political reasons to do some analysis. So that's where this ethical AI comes into play, where it has to focus more on developing frameworks, guidelines, and then certain where fairness, privacy, and everything is preserved. And then we have others use cases like automated machine learning, where it focuses on learning how to do machine learning by themselves. These models learn themselves to how to do the machine learning. And then there are other things like advanced in natural language processing things, try to learn more about how humans speak, how they express themselves, and how to understand them better, like the accents, different languages, and all of these things. And then finally, there's this advanced data visualization and exploration, where not stopping from the usual data, there's other plethora of video data, image data, and all of these are going to be used in the data scenario in huge cases, and are currently used now as well. So these are few of the future applications. And if we move on to real world use cases, since all of these sessions are focusing more on healthcare, I have compiled a set of real world use cases in healthcare as well. If we move on to the next slide, please. I have listed some of the real world applications in healthcare where this can be used for medical imaging analysis. So I explained in the previous slide that there are improvements in the technology of computer vision and image and video related data algorithms. So using this technology, we can use ML algorithms to so when we use images for the neural networks, we usually call it convolution neural networks, CNNs. So we can use these CNNs to analyze medical images such as X-rays, MRI, CT scans, and these things to predict or analyze what kind of condition that is there. And then we can identify tumors using segmentation, and then some issues with organs and bone fractures, all of these things using the imaging technologies. So currently Google's DeepMind is developing a CNN-based algorithm that detects diabetics and using retinopathy. So these are like few examples of what are the use cases of medical imaging, CNNs in the medical imaging analysis. And then we can use ML to clinical decision support systems. So we have evidence of previous scenarios. So they can analyze the patient data, medical records, lab reports, and all of these things, and then help doctors and other professionals in the healthcare sector take better informed decisions when deciding the treatments for the patients, and then other related aspects. So there's a company called IBM Watson's Health that offers like this cognitive computing platform that sort of provides this clinical decision support system for different areas such as oncology, cardiology, and other medical specialties. And then we have improvements in drug discovery and development, where it sort of ML sort of accelerates this rather than it was done by a person. It sort of accelerates how these toxicity tests and all of these things are done. So that's another use case in healthcare. And then, as I mentioned, such as personalized marketing and shopping, it can be used for personalized medicine. So again, analyzing the medical history and all of these things, ML can be used to predict the medicine for the patient. So there's already a tool that uses ML algorithms called Foundation Medicine, where they analyze the genomic data from the cancer patients, and then they recommend like target therapies and the profiles where they should be provided. And then we have remote patient monitoring and telemedicine. So using ML powered monitoring systems that monitors on the video, we can track patient health parameters, and then we can use these platforms to use ML algorithms to do remote diagnosis without a in-person doctor tending into the person. We can improve the healthcare system with this application. And finally, similar for financial fraud detection, we can use ML for algorithms for healthcare fraud detection and billing optimization, where it can identify fraudulent activities and then billing errors and all of these things, and optimize the process of the hospitals and other institutes using the healthcare sector. So these are few real world examples of applications of machine learning in healthcare sector. Since we are going to focus more in healthcare in the next sessions. I have included them here so you can get an idea of what things that you can look into when you are working on your hackathon and then when you are listening to the other sessions. So sorry for breezing through the slides because I felt like I'm sort of like going to not take enough time to explain the latest slides. So if you have any questions about the session, so this is the content that I have prepared for the session. So if you have any questions that you want to ask about whatever that is being presented, please feel free to do so. I'm more than happy.
Yeah, we would like to open the floor to questions. So please feel free to ask any question or seek clarification on the topic discussed, or you can put it on the chat.
Yeah, so I saw someone asking question. Is it so? Amani asks, is it better to go the data science or AI path? So as I mentioned, these are like two different areas, but then what they have in common is machine learning. So it depends on the personal preference, I would say. So I can't say one is better than the other and one has more opportunities than the other. It depends on what you have in your mind that you want to focus on. So at the end of the day, they are sort of interconnected entities. So it's not like exclusively separate from each other. So I guess it's depending on your personal preference that I advise you sort of do more research that what your current interests are and which one aligns with the path better, and then sort of take the decision, because I can't say one is better than the other. And then if Lal asks if I need to start career path with ML and data science, where is the point I have to start my roadmap? So I would say if you are looking into career path with data science and ML, you have to start sort of learning into the basics of this field. Like in my case, my base was statistics, but then later on with my career choices, I started to learn about computer science and IT. So there are a lot of sources out there, such as Coursera and all of these uh, platforms that provide like certifications and all of these learning opportunities for you to learn. So I sort of think that if you can start sort of looking into Python language in courses or any other language that you think you want to use in data science and machine learning, and then looking into sort of data visualization tools that can be used to give insights, and then sort of start working on these scenarios, and then sort of slowly easing into using sort of giving solutions to the data. Like you can use Kaggle to sort of start working on using data to solve problems, but then you have to have basics in as I mentioned, like some kind of computing language, and then some kind of data visualization technique, and some kind of like understanding of statistics. So that's like I think how the roadmap is. So another question is, hello, you talked about the domain experts. In the case of WID's Datathon, are there any experts to ask our questions? So as it sort of focuses on healthcare, I think you can ask, if you have any experts in that sector, you can ask them away. Or I guess in the case, internet would also be another good expert if you sort of look into it in a logical manner. Yeah. The emerging opportunities for the business analyst in the science field or AI field. So I feel like business analysis is also something that goes along the lines of data science and data analysts. One category of careers in the data science field, and so I feel like there's a lot of opportunity to business analysis in the data science field. So think someone asked, would like to know whether the presentation videos are available for participants. I'm not really sure. Maybe Sweta or someone would be able to answer that question.
We will email the relevant resources.
Yeah, so you can have the resources. And someone asked, in practical world or industry, is the difference between data scientist and data analyst. So as I mentioned, data analysis is like one part of the data science life cycle I showed you guys earlier, where we sort of analyze the data and we sort of visualize it, and then we clean data and all of this. But then there comes the machine learning part of it, and all the other aspects that I've mentioned earlier, where there are data engineers who sort of work with how the data is stored, how it's pipelined into the problem that we want to solve, and all of these things. So a data scientist is a person who would have an understanding of all of these stages and can work in most of these stages. For certain degrees, I won't say they are experts in all of these stages more than like other people, but then most of the time in the current scenario, even in the Sri Lankan context, we see there are career titles as data analysis, data scientist, but they might still be working on one of these things, and then there would be a data analyst that's doing more than there's like the career profile of data scientist as well. So I think that's the difference between these two terms. Someone asked, what are the qualifications should we have to apply for an internship? So in terms of after university internships and all of these things, I think it's sort of like once you have worked on a certain sort of degree or something, then you usually move into internship like the industry training. But then if you have completed, like there are a lot of, as I mentioned, online sources as well to learn. So if you have completed this and you contain the skill set and you can demonstrate in like an interview or certain scenario, I think you can apply for an internship if there's opportunity, and then you can demonstrate your skill set and you can go forward with that as well. Yeah, I think there was a lot of questions, and thanks everyone for interacting with the session. If there were any
There is a
there's a question about what projects should we do as data science and AI undergraduates. So I feel like I'm not really, I can't say that one project this is like better thing to do. But if it sort of covers all the life stages of the life cycle, and then it sort of covers some kind of a ML algorithm or some kind of a learning method that we discussed, and it sort of can demonstrate your understanding and sort of abilities and skills in these stages of preparation of data, and then analyzing data, and then predictions and feature engineering and all of these. It would be better if these projects would add more value to your profile and then would sort of give you an edge when compared with the other projects that there would be. And as I mentioned, there's a lot of areas that are merging in the industry, such as natural language processing, large language modeling, and then there's a lot of inclination to auto ML, and then towards the image vision, and then other this kind of data, which is not the simple static data that we see. So if you can sort of like explore more into the new trends rather than looking into a project that focuses on something that has been done for years again and again, it would be helpful. Also, the sector that you are focusing can give like more value to the project. For example, if it's like a project that focuses on like a severe illness or something like that, then it would obviously have more value because it provides solutions to real world problems. So yeah. So someone asked, could you please explain ML pipeline briefly? But I think I explained it in the data science life cycle and how ML things are done. Priyanka says, I'm working on air transport sector and want to analyze data collected, etc. in my company. Actually, I want to make a data analytics project using my data collection. Is there any domain expertise to get an idea on making project? As for the domain expertise, I'm sorry, I'm not really sure. As for air transport sector, but I guess there's a lot of resources out there on the internet that can be used for this. But as far as my knowledge goes, I'm sorry, I'm not really in a place to answer that. So someone asked, what is the job role difference between data analyst and business intelligence analyst? So I think these are sort of like terms that are coined by the organizations depending on their use case. But I feel like they merge in most cases. So business intelligence is essentially deriving insights or creating insights from the business problem that matches the business problem we have. So most of the time I see business intelligence analysis doing all the tasks that data analysts do, and they focus mainly on sort of like analyzing the data and then generating visualizations and then transforming them into business insights. But then data analysis do the same things. So I wouldn't say there's like a stark difference between these two roles, but then there would be minor nuances depending on the organization that they try to coin them differently. And someone asked, is it good to go directly as software engineering intern and change the path to machine learning, or go as machine learning intern if I get? Again, it's personal preference. There's no proven way that it says this one internship is better than the other. It all comes down to how they are going to utilize how you are going to utilize the opportunity given to you. Usually if it's a software engineering intern, then you get a solid understanding of how the computer science or IT work there in the organization, and then you can learn ML online, and then start slowly incorporating the machine learning that you get from there and incorporate it into software engineering and progress that way as well. And if you go as an ML intern, I still think you might have to learn aspects of software engineering along the way while you are doing the internship. So I would say it sort of boils down to how the personal preferences and what are the opportunities in the internship itself as well. So depending on the organization that you join, some SC internship might offer best of both worlds. I would say, like, it would offer male opportunities as well depending on the organization. So yeah, that's what I think. So but then having a solid understanding of software engineering itself is also a good thing, which you can use to ease into ML. But then ML essentially uses software engineering aspects to a certain extent, so you will anyway have to learn that as well while you are doing the internship. At least that's what my understanding from what I have learned in the field.
Yeah, okay. As we wrap up today's workshop, I'd like to express our gratitude to Ms. Sachini Bamunusinghe from London Stock Exchange in Sri Lanka for her valuable insight, and to all of you for your active participation. So before we end the meeting, I would like to request everyone to switch on your cameras to take the picture of today's session. Yeah, okay. Thank you, everyone. We hope you leave today's session with a deeper understanding of data science and machine learning. And don't forget that we have more exciting sessions lined up. So mark your calendars and stay tuned for updates on our upcoming events. Thank you, everyone, for joining today.
Thank you. Bye-bye.
Thank you.
Thank you, everyone.
Thank you. Thank you.